Hassler here. I'm going to work through the lesson and explore for 8.1, How Many Fruit Flies? It says a scientist is conducting research on fruit flies. They started with 30 fruit flies and the population triples every day. So question 1 says, how many fruit flies does the scientist have after one day and how do you know? So I have to go back up to this box and think, okay, there's 30 fruit flies to start and the population triples every day. And triple means, multiplying by 3. And so on day 0, I'm actually going to make a table. I feel like making tables have been super helpful this year. And so I'm going to make a table. And I'm going to have days and number of fruit flies. So the first day is not really day 1. We're going to call it day 0. Day 0 to start, I had 30 fruit flies. After day 1, my population has tripled. And so after one day, I now have, 30 times 3 is 90 fruit flies. And that's because we did 30 times 3. Says, how do you know? So I did 30 times 3. Does the number of fruit flies increase by the same number each day? So again, I want to keep going with this table here. And so I'm going to say D for day, number of fruit flies. We had 0. Day 0 was 30. That was the starting amount. Day 1 was 90. Day 2, if I triple that, right? So I'm going to say times 3. Times 3. If I multiply 90 by 3, I'm going to get 270. Okay. And so it says, does it increase by the same number each day? And the answer is no, right? Like from day 1 to day 2, I'm going to add, it's like saying that I'm going to add 60. But then from here to here, I'm going to add way more than 60. Okay. Looks like I'm going to add 180? And so, no. You add a different amount each day. And so I just want to make a little note. That means that this is not arithmetic. In fact, we've talked about this before. This is actually geometric. Geometric because I'm multiplying by the same number each time. And when we talked about being geometric, we talked about the number you multiply by being called the common ratio. So I'm bringing back this terminology. Okay. Complete the table. Write an expression that can be used to calculate the number of fruit flies in the population over the course of several days. So again, they've started making this table for us, which we had started to create up top. And it says day 0, that's my initial. I'm going to highlight that and say that's my initial number. And we're going to be tripling. So I'm going to be multiplying by 3. In fact, for each of these, I'm just going to on repeat, multiply by 3. Makes it seem pretty simple. So on day 1, I would have 90 fruit flies. And on day 2, I'd have 270. If I triple that, I get 810. If I triple that, I get 2,430. And if I triple that, I get 7,290. Whew, that was easy. But this middle section says expression for calculating the population of fruit flies. So if I know the output, I could easily come up with, multiplying by 3 each time. But what if 4 says, what about day 10? So should I just keep multiplying by 3? Surely there has to be another way I could approach this. And so we're going to talk about that. So for day 1, what we did is we took 30 and we multiplied it by 3. That gave us 90. And for day 2, we took 90 and we multiplied by 3. But really, what I could do is I could say, well, I got 90 because I did 30 times 3. So I could rewrite this as 30 times 3, that's the 90, times 3. Same idea down here, right? This was 270 times 3. But really what happened is I'm taking this 30 times 3 and I'm multiplying by 3 again, and then I'm multiplying by 3 again. And so really I really could say is I had 30 times 3, that was this first one, times another 3 times 3 again. And it turns out that I can repeat this process. However many days there are, that's the number of times I've multiplied by 3, right? 1, 2, 3, now multiplying 4 times. So I'm taking that initial 30 and I'm going to multiply by 3 4 times. And for day 5, I'm going to take that initial 30 and I'm going to multiply by 3 5 times. And in fact, I can translate this over to an equation. This really turns out to be 30 times 3 to the first. And this is really going to be 30 times 3 to the second. And this is really going to be 30 times 3 cubed. And this is going to be 30 times 3 to the fourth. So that means this is 30 times 3 to the fifth. And now I'm going to take this idea and, it says on day 10, how many fruit flies will they have? Well, how many I started with, 30. I'm multiplying by 3, and since it's day 10, I'm going to do that 10 times. But instead of saying 30 times 3 and writing 3 out 10 times, I'm going to use that exponent. So if I calculate that in my calculator, I get a really big number, 1771470. So remember, you put your comma every 3. So you got 1,771,470. So let's just talk about a couple things. 1, 30 is my initial. Let's label that. 3 is my common ratio. And in this case, this exponent was the number of days, or number of times multiplied by 3. So 5 says, write an expression for the population of fruit flies on day n. Okay, so let's see. I've got 30 as my initial. I'm multiplying by 3, but instead of 10 days, I'm going to put n for days. And then it does say write an expression, but I actually want to turn that into an equation. And so I'm going to say population after n days. So I got 30 times 3 to the n. Okay, so it looks like we have a geometric sequence. I'm multiplying by the same number each time. And I can turn that geometric sequence into an equation. And so let's talk a little bit more about that. Let's go over here to our quick notes. All right, so in our quick notes, a few things that we want to say are that we have geometric sequences. So we're kind of bringing this idea back. So geometric sequences show repeated multiplication by a common ratio. And we called that common ratio R. And so remember what we're doing is we're saying, hey, I have some number, if I'm creating my list here, right? And so we're actually going to say that this is going to be, if I have my first term and my second term and my third term, right? And then I would be multiplying by some number. So multiply by R in order to create this list, okay? And so if I want to write an explicit rule, so I'm going to say the word explicit rule, that just means write me a function. We would have f of n is equal to f of 0 times r to the n. Now let's talk about these things here. And so f of n is just the number in the list. Okay. F of 0 is the 0th term. So we've talked about this idea of needing to work backwards. If I'm starting with the first term, I need to work backwards to get that 0th term, which means I'm going to divide by r, right? If I'm going backwards, the opposite of multiplication is division, okay? R is the common ratio, the number that I'm multiplying by, and n is the term position. Like, what spot in the list would you be in? Now, I intentionally left this space over here because I want to review arithmetic sequences. And so it's been a while since we've talked about either of these things. And so remember that arithmetic sequences is repeated addition or subtraction. So I'll do addition slash subtraction. And so again, if I have my first, my second, my third, what we do is we are going to add or subtract that same number in order to create that list. And so I don't think that we ever had a formal explicit rule, but the formal explicit rule would be f of n is equal to f of 0. Excuse me. So again, I have to go back to that 0th term. And then plus or minus, depending on whether the common difference is adding or subtracting, the common difference times n. And again, that means that I'm going to have to go backwards to get that 0th term. Okay, so 0th term. Term. All right, so review of arithmetic, review of geometric, but now we have a formula, a rule that we can use. And if we go back to this previous example, write an expression for the population of fruit flies. The output, f of n, is equal to the initial, that's how many I had on day 0 before I started my experiment. F of 0 was 30. R, my common ratio, is multiplying by 3 to the n. And n is where I could put in, any day, whatever day I'm looking for. So your job is to work on the check your understanding and ask me questions, and then your homework will be the 8.1 practice.